Okie dokie. All right, we're going to have a boy push his mother. Hopefully she's on a sled going across the kitchen floor. And we want to pay really close attention to the word constant speed. Okay, here's a representation of a mother whose mass is 200 kilograms. Hefty woman. Okay, force of gravity equals mass times gravity. 200 kilograms times 9.8 meters per second squared. Here's your Newton. Force of gravity equals 1,960 newtons. All right, my force normal backwards is the same thing as gravity, 1,960 newtons. Now I have to figure out what's my force applied. And whenever you have force applied, you also have a force of friction working in the opposite direction. And because of the word constant speed, when I add up my forces in the x direction, that's going to be 0. All right, so let's just look at the boy, and let's look at the mother getting pushed across the floor, and I'm going to write my start of my equations, all of them. The summation of all my forces is considered force net, and I say, well, is it equal to mass times acceleration? But because of the constant speed, A equals 0, so this whole thing equals 0. So now I can write my force net, all my summations of my forces are going to be equal to 0. What are my two forces? Force applied plus negative force of friction. And all this is going to be equal to 0. That means if I add force of friction to both sides, what do one side of the equation you do the other, it clearly shows that my applied force is going to be equal to my force of friction. All right, well, what is my force of friction? Well, look over here. My force of friction from the reference tables is equal to mu. That's the sloppy U and M together. That's what this is. Mu times force normal. Well, we already know what force normal is. Force normal is right here. Shoo! Looking for that. That's what we're trying to find. Right? All right. And well, what's applied force? Well, the friction force, moving this little thing over here, is all this information. So I'm working over here, and I'm working with this information. So my applied force is my force of friction. What do I know for my applied force? I am pushing with 300 newtons. Got that from right here. Shoo! So 300 newtons is equal to my force of friction, which is also equal to mu Fn. So I could also write 300 newtons is equal to mu, which I'm looking for, times force normal, 1,960 newtons. Divide by 1,960 newtons both sides. 1,960 newtons both sides. Da-da-da, this cancels out. Mu, no room to write it. This over here. Mu is now equal to 0.15. That's my coefficient of friction.